RSC from scratch part 1 server components challenges. So at the end of his incredible article, Dan Abramov gave these challenges, and most of them are pretty trivial, like adding random background color. But around the middle, we're going to do this comment section, which is basically going to be server actions or a remote procedural call from the client to implement a function on the server. And then around the end, we are going to do client components. Now, in this video, I'm planning on doing everything ad hoc. This is going to be my own version of every single thing. I'm not going to use a react-server-dom-webpack library in this video. I just want to show how to solve some of these challenges, what some of the problems are when you're trying to implement these things, and then I'm going to show hopefully whenever I'm solving these challenges with my own things later in the next video when we show the official way of doing things, hopefully you'll see part of the reasons why they made some of the decisions that they did. So we're going to go through this and we're going to do everything my way, which is going to be a little bit not great, but the idea is going to be to see what the problems are and how we're going to try to solve them. And so let's get started with the first challenge, which is adding a random background color to the body of the page and add a transition on the background color. When you navigate between the pages, you should see the background color animating. And then for this, at first, we're just going to do this on the client side, but later I'm going to do this through a server action, and you'll see we can have a cookie. We can remember what our favorite color is. So let's get started by doing this on the client side. It's really simple. Okay, so we're back here on our website, exactly the same as Dan Abramov left it. All the code's the same, 60 lines client, 60 lines of SSR, and about 160 lines of RSC, including all of the JSX over here. And so, like I said, we're just going to do this client side at first. And so the way that this works, luckily when I started writing for this function out, GitHub Copilot stole something from Stack Overflow for me, where it just makes 3 hexadecimal numbers within 256, and it just makes sure that they're 2 digits long, and then we get a 6-digit long number by combining the 3 of them. And then we take that and we're just going to look on the body, and because he said he wants the whole background to change, and so we're going to take that, we're going to add some CSS dynamically with JavaScript here, where we just make sure that it's kind of a smooth transition in between these random colors. And he said he wants it to happen on every navigation, so we're just going to do it every time that this function is ran. Simple as can be, about 20 lines of JavaScript, and this website's a little bit more interesting than it was before, but you know, nothing too exciting. We're going to do a little bit more here as we go along, and I'm going to show a couple different ways that we could have done this. All right, let's move into the second challenge here, where he asked us to implement support for fragments in the RSC renderer. It should only take a couple of lines of code, but you need to figure out where to place them and what they should do. And he kind of told us where to place them in the RSC renderer. Let's figure out why you even want fragments in the first place. Like in this blog layout in the index page, there's a section, but it doesn't really do anything. There's no CSS for it. It doesn't really serve any purpose. So let's see what happens whenever we just get rid of it. So everything's just right there in the main tag, and we don't have any superfluous HTML. So let's save that and refresh, and we will see that we have officially broken the website, and we get this error, not implemented. So if we go down and look to see where that error is right here. So in the render JSX to client JSX, this is our RSC renderer, where it's just trying to make everything into valid HTML. So things like functions and other things that can't be properly serialized over the wire need to be, you know, he runs the functions, etc., to make them into things that we can send over the wire. We haven't covered the fragments yet, so we have the not implemented error here. Let's just go ahead and see what our JSX looks like right here. So if we save this and we refresh and we look down and see what we have underneath, we will see that we have the JSX down here somewhere. Right here, and we can see that we have the symbol for React element, so it's somewhere in this block right here, but we don't cover the kind of JSX type that this is, which is a symbol for React fragment. And so it's just going to be just like this, where we can look to see what the symbol is. We can do the exact same thing here. And so let's just do it right at the very top of this block. We can save it right here, where we just go through and we look to see what each of the children are, and we're going to run this function on each of the children. So we're going to act like the fragment isn't even there. We're going to pretend like it's not there, even though we need it, because every JSX element has to have a single parent element, and so it just makes our life a lot easier. So now here in the main area, we just have all of the content instead of that superfluous section tag. Let's keep going. So the third challenge is, once you do that, change the blog to format the blog post as Markdown using the Markdown component from React Markdown. Yes, our existing code should be able to handle that. So let's look at the existing code really quickly. And so the way that the post component works is that we just read these files and we're just passing in the slug and we try to read the appropriate slug and text file. And the text files, we can't do any kind of formatting inside of it. So like if we try to make this into a header, an h3 component, we're not going to actually see that. We're just going to see the text that we're reading from the file. So if we want to get the extra formatting that we can get from this React Markdown component, all we have to do is we install it from npm, just like the other packages. And then what we're going to do is we're going to import it. And then we're just going to change out these text to MD files right here. And then we're going to change out this article to Markdown components. And then when we save this and we move these Markdown files over, which have some Markdown formatting in it, and let's get rid of these guys just in case. And if we save everything and we move over here, we can see that we now get the formatting from the React Markdown component. We didn't have to write any additional code, so we get the composability of a new component that has functionality that we don't have to write, and it all is on the server. That's the beauty of these server components, is that this would actually be like quite a bit. It's 130 kilobytes. Gzipped, it's 44 kilobytes. So all of that happens on the server though. We don't have to import anything on the client over here. We just import our normal code, which is a little hefty right now, but we're not bundling or anything. So as you can see right now, this is the beauty of server components. We're starting to see this composability and then this lightweight that we get from leaving this stuff on the server. So let's keep moving. Here we are on the fourth challenge. The React Markdown component supports specifying custom implementations for different tags. For example, you can make your own image component and pass it into the Markdown component where it replaces all the image tags. Write an image component that measures the image dimensions, where we can use an npm package that automatically admits the width and the height. It's really hard to do by yourself, so I did use an npm package, and it just needs to know what type of file it is and how to read it. It's pretty hard to do. I was going to do it myself, but let's just bring that in, and we are going to say what width and height it is, because as of right now, it is going to be broken for two reasons, but we'll explore the second reason in just a second. But if the content relied on the size, it would be totally broken. It's like, it doesn't even know how big this image is supposed to be. So let's bring that in and let's save this now. And when we go over here, the image component is going to be trying to read it out of static images, and you can see it's right there, so it should be able to work, one would think. But when we refresh, it's still going to be broken. It can't quite get it. So let's think about why this would be. Well, if we look in our SSR server, which is responsible for serving our static assets, then we can see it's only serving up client.js. It's the only static asset that it knows how to serve up. So let's change this around just a little bit, and let's bring in this get static asset file and use it for anything, any path name that includes a period. We could make it so that it's like near the end or something, but we're just going to do it where any path name that ends in a period tries to load something from this get static asset file, which just looks at what the extension is and tries to set the appropriate content type. Nothing too crazy. And I just want to point out that because we know the width and the height, if a layout relied on this insanely large image to be taking up this much space, even before it loads in or whenever it's broken, the layout's still going to be the way it's supposed to be because we know the width and the height. And once again, all of that is left on the server. Nothing had to be loaded in for that new image library, which once again is quite large, and I'm never 5 kilobytes, but it adds up. I had the client file still outside of static. I moved it over to static now, and so when we refresh, everything loads in just fine. You can see here, and we still have our client-side navigation with the changing colors, and we have images. Let's keep moving. All right, the fifth challenge, this is where things get spicy, and it's pretty exciting. Add a comment section to each blog post. Keep the comments stored in a JSON file on the disk. You will need to use form to submit the comments. As an extra challenge, extend the logic in client.js to intercept form submissions and prevent reloading the page. Instead, after the form submits, refetch the page JSX so that the comment list updates in place. Let's do it. So I don't want to waste too much time on this, but I want to talk about one wrong way to do this and why it's wrong. So as you can see, we're intercepting on the client side, doing a little bit of validation. Nothing wrong with that. Here's what's wrong. Instead of just going back to the server that we're talking to normally, this one is going directly to the RSC server on port 8081. And so with this, we're just completely ignoring the SSR server here. We're not using this one at all. It's just fetching directly from the RSC server. So we have to do this CORS song and dance, and so that's an issue, but it's just a symptom of the issue. It's not the real issue here. And as you can see, this works just fine. Like, you know, like we can post it. It's going to refetch to JSX. It's going to be exactly what he asked for. So it kind of works, and that's not really the problem, but it's a symptom of the problem, like I said, because so if we look in the flight fixtures, like the React example test version of like React server components, we can see that the version of the SSR server is called global, and then the version of the RSC server is called region. So it's supposed to be data local resources like databases and RSC, and then with the global, it's a Webpack bundle that we SSR. So bundling is really important here, and we'll talk more about that later. But there's supposed to be multiple RSC servers. So like the client, how is it supposed to know exactly which one that it's supposed to be dialing into? That's the first issue. And then the second issue is that it should be going through the SSR server anyways. If we look down here, we can see that the official way of doing server actions is they just have a proxied header with RSC-action, and then they send the entire request over to whichever regional server it's supposed to go to. And so that is why this is just the wrong way to do it. I mean, it technically works, but it's not like, you know, the idiomatic way of doing things. So let's move on to the right way to do things. And one more thing, it's not progressively enhanceable either, because you know, we're going to a completely different URL than where the website's hosted. So we should be trying to be going through so we can progressively enhance the form. All right, so let's see how to do things the right way, shall we? So over here on the client, I took out all of the special form logic. This is going to be fully progressively enhanced. It's going to work whether JavaScript is turned on or not. And so let's look at the HTML to see how that works. Each of our forms are going to have a method and an action. Our server logic would work whether the method was defined or not, because it would just be a get, and it works with gets or posts. But we're going to need to define the action for each one, because what we're going to be looking for is this /API/. That's how we're going to define all of our server actions in this version. And so in the comments, we're just going to define the name and the content for the comments, but we're also going to hide the slug in a hidden input down here. And that's how we're going to know which post we're going to need to put the comment into, which JSON file to put it into. And then when we submit, with JavaScript turned on or not, this is still going to work. So let's go ahead and disable JavaScript, but we're actually still going to have an error here. And so let's look at what this error is. And so, we just went to API comment. We didn't change the location. So let's look at our server logic to see why this didn't work. So let's start with the JSX just so you have an idea how everything works. So each blog post page takes in a slug, and that's how it makes the post component by reading the Markdown file. Underneath that, we're going to make a comment form and a comment list that both take that slug as well. So the way the comment form works is going to be almost exactly the same HTML that we saw before. The only dynamic part is that hidden input where we put the slug. Now, the important part up here is the action where we define the URL that the form is going to be sent to. If you don't define an action, it just sends it to the same page. One thing you could do is just look for post requests and then look for the headers or whatever from there, and that's how you can do your actions. But for whatever reason, I wanted my actions to work with get or post requests, and so I'm just going to look for the /API/ from the action here, and we'll get back to that in just a second. But here, let's look at the comment list really quickly, and we can see that it just reads the JSON file, very similar to the post component. It's just going to await read file, and whatever that file slug is, it's going to look inside of that that directory and look for it and map through and make these comment components with it. And with the comment component, I put a bunch of silly inline styles. It just makes a fancy box around the content, and it puts the author and the timestamp at the bottom down here. And so if we look in the JSON file for the post that we were just on, we can actually see that the post actually went through, the comment went through. So if our form submission is working, then why does it break our website whenever we do it? So look, it's sending us to API/comment. Remember, that was the action of the form. It's just the natural behavior of the browser to try to send you to where the form is telling it to. We haven't told it to do anything else but to go to API/comment. So let's look through the behavior of the server logic to see where this is happening. So we're going to port 8080 API comment. That's our SSR server, remember. So let's look over at ssr.js over here, and we can see that we are looking for any path name that starts with API. Remember, we could have looked for post requests, but this is what we have chosen to do. So we are awaiting this serve action function. So let's look at this asynchronous function down here. What this does is it logs the URL right here, API comment, and then underneath of it, it awaits this read form function. This is nothing special. It just looks to see if it's a get or a post, and then it behaves appropriately, and it looks to see if it's a JSON file. If that's the case, it just parses the body. Otherwise, it assumes it's a normal form. And so then let's look underneath here to see what we're doing after that. We're just sending it over with the exact same path name. We can attach any search parameters or whatever, and we're sending it over to the RSC server, and we're going to post it as a JSON content type because we are stringifying the body that we found here. So remember, the SSR server is basically a client. This is basically going to be our client behavior that we're doing later because we're just trying to take in the RSC server's response and pass it over to the browser. So let's look at the RSC server and see what it's doing. So the RSC server is, again, looking for that special path name that we have defined. Another thing we could have done is search parameters. There's a lot of ways you could do this, post request, like I said. And so we're just going to slice off API and define the action as whatever we find afterwards. So that's going to be comment here. Remember, C-O-M-M-E-N-T. And so we're going to run this action router with that action and give it the request and response. So down here, the action is going to be comment. So we're going to import actions/comment.js and run the default export and then give that the request and response. So down here in actions/comment, because that is the action that we're trying to do, this is where the magic happens. So here we have this function that we're exporting where, again, we read the form. Here it's going to be JSON because remember we have done that. We changed it over on the SSR server. And underneath, we're going to get the content, the author, and the slug. We are going to import the comments JSON file beforehand, and then we are going to process the comment, push the comment onto it, and then write a new JSON file by stringifying everything. And then we are going to go ahead and set this location header, and we log it afterwards. So you can see everything is working here. Serve action, we have the raw body, and it gets processed correctly all the way over to body in comment.js, and we're supposed to be redirecting back to the correct page. So what is happening here? Well, the problem is over here on ssr.js, when we get the response, we're not doing anything special with it. That header that we set over here on comment.js, we haven't done anything with it over here. So what we need to do is we need to actually get that location header from the response that we get from the RSC server, and then we need to set it on the SSR server as we send it back over. And now, if I save this and we go back over here and we refresh this page, we're going to have to wait for the server to boot up. And so now if I go down here and I say, I am a guy, this is a comment, and we post it, it's going to send us back to this page. Remember, we have JavaScript disabled, but everything works without JavaScript. It's progressively enhanced. So now let's see what it can look like with JavaScript enabled. So if we just enable that here, we have this form listener that we brought in over here. It's just looking for that special action, that special path name that we have defined. Otherwise, it just returns. And if it sees that path name, then it prevents the default behavior and just tries to process whatever form that it's on, so it can navigate back to whatever location that it gets from a header, or it's just going to go back to the exact same page that it was just on. Nothing too special, but let's go ahead and check this out. Whenever we do it this time, we can see that it's going to not have to replace the entire page. Whenever we do that, it will change the background because we've technically done a navigation, but we're going to have this on the bottom. So we're not doing any error handling. So if we want to, we can just keep posting the same comment over and over. Let's do a couple things to make our server actions a little bit more resilient. So at this point, I bring in a style sheet, and all we have to do for that is just need to make sure that we are writing it to our initial HTML string. So right here is where I import it, and it's nothing too crazy, just makes things a little bit more regular, a little bit more responsive. And then up here for a few more server actions, I just did some stuff based around the background color, where we can choose a favorite color, and then it will load in with that every time, or we can just go through some random ones to set as the cookie. If we're afraid of commitment, we can just check out some random colors for a second. And so what's important here is that we need to make sure that we are setting all of the appropriate headers. Before we were just looking for location, but now we are going to cycle through all of the headers, and all of the headers will be written to the new response because we don't know what we may need for what action. And then the random one over here, we can see we are actually running the random color function. I chose a different one for this, and so the random color function is going to run on the server instead of on the client. So let's see what we're doing on the client here. So instead of doing that, we are importing this new color change function, which is just seeing if we are choosing a color on the client. If that's the case, it's going to set the background to that, and then it looks to see if there's a cookie. If that's the case, it sets the background with that, and then lastly, it will fetch a random color with this one search parameter that we are looking for. And if that's the case, then the fetched color will be that. And so we have the search parameter just to see if we want to set a cookie or not. That is the only difference if that search parameter is set. And so this is how easy it is to implement more server actions once you have the basic foundation set up. And let's keep moving. So before we move on to the next challenge, I just want to talk error handling really quickly. As of right now, ever since we moved things to the server, we don't have any error handling. You can even put in an empty comment. So enabling error handling on the server and rejecting things is pretty easy. So if we just do this and we save, then we can no longer enter empty comments. But what are we going to do to show users that they can't do it? Well, we've already put in this little p tag with an error ID, so we're just going to exploit that. It's going to be very, very simple, where our show error message function is just always looking for something with an ID of error, and then it will show some text content for 5 seconds before hiding it. We also brought in this clear form function for successful submissions. And so up here, we are just going to check in our responses if we have that error response. Very generic, but assumedly this is something that a framework would provide, and you wouldn't really have to do much more than this. So now if we try to post something in here, it'll say that we need to have an offer. If we don't have that, it'll say we need to have some content. And then finally, if we post both of them, we can now post a new content, and it will refresh it on the same page. Ta-da! So my whole point in showing this is to show that there's no such thing as full server or client-side validation, really, if you want to have the best experience in this model. We need the two working together, and the one knowing what the other one is doing in order to be able to show this error in line and without having to refresh the entire page. We could do that no problem, especially if we wanted to be fully progressively enhanced, but in order to have the best experience, we need the server and the client to be knowing what one expects from the other. All right, that was server actions. Let's move into the 6th challenge. Pressing the back button currently always refetches fresh JSX. change the logic in client.js so that back and forward navigation reuses previously cached responses, but clicking a link always fetches a fresh response. This would ensure that pressing the back and forward buttons always feels instant, similar to how the browser treats full page navigations. So let's go over and check to see how client.js navigates right now. So over here in client.js, we set the current path name to the window.location.pathname at the beginning, and then the navigate function just changes that over to whatever we pass into the navigate function, and then it goes and fetches the client.jsx. We run this color changer function, but that's not important, and then we double check the path name at the end, and then we render the client.jsx after that. So down here, I'm going to add the sleep function to the fetch client JSX function just to make this all really obvious, to make it seem like we're actually fetching the JSX from across a different server. And then we are going to go over here and change it to background to hot pink for the 2 seconds that we're waiting for each one to load so we can really see what's happening here. So let's go over here, and when we refresh, we're going to have it dark purple, the color that we have at first, and then when we click on something, we have to wait this whole time, and then finally it loads in, we wait, finally it loads in, and unfortunately this is true about when we press the back and forwards buttons as well, so it's way worse than a traditional multi-page application. So the way we're going to fix this is with just a plain old JavaScript object. Nothing fancy like a map or a set or anything like that, although we could do that. And so as soon as we load in, we're going to take the current path name and load in the initial client JSX for that. And then every time we navigate, you have the option of passing in the cache being true. But normally we're going to assume that the cache is false because most navigations we don't need to cache. And so we check that if you have passed in that option, and if we have that in the client JSX cache, then we're just going to go ahead and render that. Otherwise, we need to fetch the client JSX for that and put it into the cache. And then we render it at the end. And then, so, like I said, for most things, whenever we navigate, we're not going to change anything. It's going to be exactly the same. It's just with pop state. That's the only time we want to pass in this option of cache being true. And then everything else down here, all of these navigate functions, everything else is still exactly the same. So now, whenever we load in, we still have that sleep function that turns everything hot pink as we load new things in. So we have to wait the 2 seconds there because it's a cache miss, another 2 seconds there. But whenever we press back or forwards, we're going to be going into that client JSX cache, and we're going to be loading in what we have for each path name there. And that is the 6th challenge solved. On to number 7. When you navigate between 2 different blog posts, their entire JSX gets diffed. But this doesn't always make sense. Conceptually, these are 2 different posts. For example, if you start typing a comment on one of them, but then press a link, you don't want that comment to be preserved just because the input is in the same location. Can you think of a way to solve this? Hint, you may want to teach the router component to treat different pages with different URLs as different components by wrapping the page with something else. Then you'd need to ensure that this something doesn't get lost over the wire. All right, let's do it. So at this point, the RSC file with all the JSX and everything, I'm about to add another component, and it's already 300 lines long. So what I ended up doing was taking all the JSX out and putting it into components and pages over here. And now you can see that the router really puts everything into perspective. And what we need to do is figure out how to tell it that this page is different in between renders. And we'll talk more about this in just a second, but let's go ahead and I want to show you why I'm adding this new component, because we have these inputs and these are perfect for showing what the problem is, but I have to go in between these 2 pages and I don't have an easy way to link in between the pages. So I added this silly component. Let me show you. And so you may have already seen it. Every time we route to a blog post page, we're doing this thing called handle post click in the popular post component that I'm about to add. and we are just storing in this clicks.json file every time that we click on one of these blog post page, or really just every time one is loaded in. And so what we are doing is we're going to show the top 3 blog posts out of all 3 of the blog posts that we're going to have here, and then we are going to have them listed here, sorted and everything, and we're going to have it done dynamically. And so then if we go into the blog layout, let's go ahead and bring that in right there, and that is the new component that we're bringing in. So now whenever we refresh this and it loads in, we have this at the very top. So now we can easily click in between these things and see that whenever we click in between, it actually preserves the name might actually be handy, but you would probably have different comments for the 2 different posts. And so these are not supposed to be the same element. These are supposed to be different elements for the 2 different pages. So how do we tell React that these are 2 different elements on 2 different pages? Well, it's pretty simple. Let's go back over here, and we just have to go into the router once again, as he told us. And if we just surround each blog post with another article, we're going to do article here, we could do div, we could do whatever, but just something with a key that we tell React this is a special thing. So he's just trying to show us this is why we still need keys whenever we are rendering these things on the server, because React still needs to know that these are different elements even though we're rendering it on the server. So now if we do this and we put that into that down there and we click onto this different one, it will now be empty instead of being filled up like it was before. Boom. Surprise. All right, on to number 8. Number 8. The format to which we serialize JSX is currently very repetitive. Do you have any ideas on how to make it more compact? You can check a production-ready RSC framework like Next.js AppRouter or our official non-framework RSC demo for inspiration. Even without implementing streaming, it would be nice to at least represent the JSX elements in a more compact way. Okay, so I'm not going to get too deep into this because I'm going to do a whole video about how to do server components right. That's going to come out after this, but this is already getting too long. So I'm just going to go over what he means here really briefly and show how we can solve this, and then I'm going to move on to the last challenge. So what he means by a production-ready RSC framework like Next.js AppRouter or their official demo, let's go into the official demo, and we'll see that he's importing react-server-dom-webpack. And here he's using the server part of a library to render to pipeable stream, and that's how we were doing the streaming. And so we're going to do something like this in our demo here in a second, and I'm just going to go through this briefly, but really quickly I just want to show what react-server-dom-webpack is here. And if we go down, we can see it's the experimental React Flight bindings for DOM using Webpack. And so what's React Flight, you might ask? And so if we go into React fixtures, these are all of their testing libraries. This is everything that they use to make sure that everything works right, especially when they have experimental new features like progressively enhanced server actions. The Flight folder here, this is for server components in general. But as you can see, they're also doing some exciting stuff over here as well. Like the ESM folder over here is a bundlerless version of RSC using plain ESM. I haven't quite gotten that to work just right yet. I'm trying so hard. But we also have over here the Flight browser, and we can see that if we refresh over here, this is going to show us the entire life cycle there. We saw the loading there, and if we look here, we can see that we have react-server-dom-server, and with that, it's rendering to a readable stream this fake information up here. And then down here, we have react-server-dom-client, and with that, we have the create-from-fetch method with which they are rendering the results with that data. And then we have the suspense, and that's key to a lot of this, is the suspense right there, which we have the loading state that we see right there. Okay, so I'm going to move in really quickly. Let's talk about, he said, even without implementing streaming, it would be nice to at least represent the JSX elements in a more compact way. And spoiler, we're going to implement streaming, but let's look at how we're doing the JSX before. I took out the server actions because we're not going to do them in this video. We'll do them in the next video in terms of doing them the right way. I just want you to see all of this logic that we're doing in terms of just getting the JSX to the client. And this doesn't even do everything. Like suspense. I told you that suspense is really important towards everything everything else that we're going to be doing, like, because we have to throw those promises the right way. So we are going to need to do a lot more than this, and we're already at 80 lines of code just to get the RSC the right way. And then we have to send the JSX over, and we have this repetitive stuff that we're doing over on SSR where we have to parse it correctly, and then we have all this stuff where we're trying to get the HTML string correct here. And then over on the client, I took out all the server action stuff, and even with the cache, it's only 70 lines of code, so that's pretty cool, even using the history API. But so without server actions, that's everything that we have in the old code. So now let's move into the new code. So the vast majority of my code is just going to be me taking parts from this flight fixture here and from the official server components demo. But the thing is, this can be a little overwhelming whenever you first look at all of it. I mean, it all makes sense whenever you just look at it piece by piece. It's not that crazy of stuff. But the thing is, it's kind of hard to piece it all together whenever you're first looking at it. So the thing that we're going to focus on in this video, we're going to talk more about it in the next video and put everything together in the next video. So all we're going to focus on for this video is how to stream a response from the RSC server to the client. So here we see we rendered a pipeable stream here, and it's the same in the official demo here. And so in our first RSC server, all it's going to be doing is creating the right element for the URL that the user is asking for, and then rendering it to a pipeable stream. That is all our RSC server is doing right now. And then over here in the SSR server, the only thing that it's doing is finding out what URL is being requested. It's going to provide any static assets if necessary. And then other than that, it just creates a new promise for data from the request. It passes along the method, it passes along the path name, and whatever headers it needs to. And you can customize the headers here, but we're not going to worry about that yet. We're just worrying about creating the stream. So it's pretty simple. We're just looking for two things here. The first thing what we're looking for is if the user is asking for some HTML, because we still don't have any HTML files whatsoever in this entire project. So if that's the case, then we know we need to establish the streaming environment for the first part. So we need to stream in some HTML, which we are going to create from the RSC response. And so we render that to pipeable stream. But this is a different render to pipeable stream, actually. This render to pipeable stream is actually the normal render to pipeable stream, because first we had to make that stream from this special plugin, this special create from node stream. This is different. This is necessary to translate the RSC response into the HTML that we need to send to the client. So then first we do that, but after that point, we can just stream everything in. So we're just going to set this header text x dash component. Seems to be a little bit of a standard that's being set. I don't know about it, but we are just going to set that header, and then that's all we're going to be looking for the other response. And then from that point on, we can just write the data into the response until it's done. We're just streaming stuff in. That's as simple as can be now that we have set up the environment. And then we are catching any errors, and we just set up the server. And here's that request function that we were using. It just returns a new response that we can just pipe into the body of whatever we have there. And so if we look at when we use the request, what we were giving it was these options for that body. Okay. Let's move into what we have on the client down here. Okay, so remember, this first version of client.js is laser focused on how to hydrate server components that have been streamed onto the page. So this first one's not even going to have a cache, it's not going to have server actions, it's not going to have anything. It's just going to have a way of hydrating that initial route, and then a way of navigating around with new server components that we bring in, okay? So first, we need a way of updating that route that we're going to be creating. And the way that you render in React is with state. everything comes from state. And how do we create state? Well, the easiest way is with a hook, and we make a functional component to use hooks. So we create a shell with which we're going to be hydrating later. And then we use the useState hook, just like we always do with root and setRoot. But then we're going to be bringing in this experimental useHook that they're still figuring out, but it's really, really cool the way that it lets you use asynchronous data on the client side. And all we have to do is just bring in that data and use it with the useHook. And then we're bringing in, we want it to be the state of the page. So we use the useState hook on that. And then we're going to be returning this root, but then we want to be able to update this in the future. So we're bringing the setRoot part of a tuple out and bringing it onto this variable that we've already created. Then we're just going to look to see where we are right now. What has the user requested? What is in the address bar? We're looking in the location API and looking at the path name of that. Then we're going to use this create from fetch method from react-server-dom-webpack client. I actually have this alias to react-server-dom-webpack on the client just to make things easier for myself, a little less typing. And so the create from fetch method, well, I'll show you the import map in a second because that's interesting too. So if we look down here in the create from fetch, all we have to do is just fetch something. Literally, it creates an element from fetch. And then we're just going to put in that special header that I mentioned earlier to tell our server that we want a new component. Okay. And so then we just create from fetch like that. And then we're going to hydrate the root with the element that we create from fetch. Okay. And then down here, we just need ways to navigate once we're on the client side. So we're just going to do the exact same song and dance where we create a new root from fetch. Then we're going to use that update root variable that we created earlier that is now tied to the root from that useState tuple. And we're going to put this new root inside of it to update the entire page. And so this is not the best way of doing things at all. I just wanted to show the very basic idea of how the life cycle should work. And so here we go. It's just 40 lines of code. I'm cheating a little bit with the navigation API by intercepting all of the events, the navigate events with that, just to keep this code as simple as possible to show how things work. I have another version here with a cache and some console logs if you want to see how things work a little bit closer up. And so, yeah, that is how the client works. So like I said, we have no HTML pages, and the SSR page isn't importing that string anymore. So how are we importing things like this style sheet? Oh, and I'll click around just to show you that the client-side routing is working. As you can see, it's only updating that one part of the page. And so then how are we getting this style sheet with these silly rounded things and everything like that? Well, the way that this works is that we actually have, with the new render to pipeable string that we are bringing in from react-server-dom-webpack, it actually takes care of all of that whenever it's rendering that root. So remember, in the router, we're always going to have the blog layout. It's always going to be surrounding everything. So once we bring in that render to pipeable string, what we can do is just define the blog layout like a normal HTML page, because this is going to be our skeleton that we're going to be putting everything else inside of. And the way that this render to pipeable string works is that you can just put all your style sheets and stuff in here like normal, and it's just going to work. And you can even have stuff like this where we have dynamic content like the author, and that's how you can have dynamic meta tags. Now, they're still working on getting import maps to work just right. Like even some of the official examples have the import maps brought in like that. They're still figuring that out. This will assumedly be fixed in the future. And so that is how we're bringing in all that stuff. And like I said, you can even have dynamic stuff in the meta tags, and you'll see I'm doing something wrong because it's bringing it in twice. I think I'm doing something wrong, but as you can see right here, we have a dynamic data in the meta tag. And so yeah, that's how we're doing everything on the client in this first version. So let's talk about the benefits that this brings us. So whenever we stream this in, we don't have any HTML shell or anything to show to the website at first. So if we have something that takes a long time, like I made this exaggerated, this is going to take 10 seconds for it to load this in. So for 10 seconds, if we didn't have this suspense boundary around this in our router, then the entire page would take 10 seconds to load in, because we don't have any index.html. We don't have anything to show them. But luckily, render to pipeable string is smart enough to know that we can already render the blog layout. We don't have an HTML page, but it renders this, and then it puts a temporary placeholder down here for the ID B0 template, loading it in, and then once it gets it, we can see down here in this script that it's looking for these things, and we can look down here and we can see let's see if I can find it. Bam, B0 right here. That's what it was looking for to later hydrate, so we could stream that in later. We can stream things in gradually as the data loads in. Okay, and finally, really quickly, before we move into client components, I'm going to talk about why we would even want or need them. So I brought in server actions on the navigation API. It's really easy. I'm just checking for the form data here. And then in the SSR, we're just looking for that path name. And this is still going to be progressively enhanced, so this would still work with JavaScript turned off. Over here, we have the action router. Everything's exactly the same, okay? So we brought all of that in, and so now we surprisingly, we can have the color change whenever we fetch that from the server at the beginning here, and then we can go over here and we can post a comment. That's still going to work, and we can go down here. We can see we can even fetch it in line. Everything's still working the way it was supposed to. Okay, so we can even manipulate these cookies over here. Okay, so we can even do all that, but notice it's not changing the color. And then over here, if we try to put in an empty comment, we can't get the error the way that we were before. So if we look over here at the console, we can see that, oh, the error is connection closed, because all of this DOM manipulation is relying on a constant stream of information from the server. So whenever we try to just manipulate the DOM in line like we were before, that's not the React way. So whenever we do things like this, all of our server actions, everything is going to have to rely on the client and the server working together. Okay, so our server actions, if we want to have errors in line, that's going to have to actually be a client component right there. Okay, but we can do some things like some loading state and stuff like that. We'll look at that in the next video. But I just wanted to finish off by talking about why we would even want or need client components in this context. Whenever we're doing the DOM manipulation, it's really important. And then we also need it for changing the headers. If you notice, like whenever we're trying to change the color here, we do actually change the header, but it's closing the connection whenever we do that. Whenever we refresh, it actually is whatever random color we were looking for there. And so you can see it's turning purple here now. And so let's go into one little thing about streaming really quickly before we finish up and go into client components. Okay, so I feel like the one file example here is going to be the best way for me to explain what I mean here. So on here, we have this model that we create on the server, and we stream it into the client, and then down here we use the use hook to stream that in, and we can see here that we just leave a loading state for a second and it loads in. So I want to really show what I mean here. So on my new version here, we are going to have the server model up here. I'm really differentiating everything. Down here is the client model, but it needs to wait on some data that's going to take a little while, right? It's going to take 5 seconds, let's say. So whenever we refresh, we're going to see that we can have this loading state here for 5 seconds. But let's pretend that this is a live data stream that we really want to get into. See, it's coming in as we're talking. It's a live data, and we really want to show this as it comes in. Just like that just happened. So the way that we can do this is by using a client component and using state, because that's how we update the DOM with React, is that we use state. So we have the data, I'm putting it into state, and then we're using an effect, another thing that needs the client. It needs a stateful browser environment to work. And so we have the use effect hook here. And so when we refresh, we see we're going to get a bit of an error, but things are still going to work because this isn't real. But we see here, this hook is not supported in server components because the server is a stateless environment. They're doing a little bit in terms of having a little bit of state on the server with React server components, but generally it's a stateless environment. You don't have things like effects that are firing in the browser. And so what we need to do here is we need to take it out of a server model. And so what we're told that we can do is that we could just put use client at the top. But you can see I've already got it here. But the thing is, the only thing that works with this is if we're using a special node loader or a special bundler that's going to be looking for that pragma. If we just write it in here, it's not going to change anything. Even if we were importing this from somewhere else, I'm not going to go through that. You'll see that it wouldn't work if we were to try to do that. What we need to do effectively is either take it out of of a server model or render it to string in the server model to get it to work correctly. So we see here now we get different errors, but we're not getting the error about how we can't run it in a server component because now it is effectively a client component. It's just mad at me for all the other dumb stuff I'm doing. Okay, let's move on. Client components. All right, here we are at the end. Number 9. Imagine you wanted to add support for client components to this code. How would you do it? Where would you start? Okay, so we're not going to implement client components with render to pipeable stream because let's look at it over here. If we look, the second thing it's looking for is a webpack map with a client manifest. Okay, so bundling is super duper important for the way that all of this works together. And I'm not going to get into that exactly in this video, but we're going to talk all about it in the next video. Don't worry. But if you look over here in the official demo, you can see that it runs the bundler every time. And then if there's nodemon running, so every time you change anything, it's going to run that bundler again. And so I just want to make things a little bit simpler because when you bring in a bundler, it makes things crazy. So we're going to bring back the rendered JSX to client JSX function, and we're going to do everything inside of this. I'm going to leave everything exactly the same as it was here, but I'm going to bring in this look. We're going to look for every functional component to see if it includes the words use client anywhere. You're not even allowed to talk about client components without being a client component in my system. So and then if it is a client component, then we're going to run the client component transform with the component and its props. Okay. And so if we go over here to the client transform, we can go in and see that we're taking the component and the props, and we're just going to go ahead and run that same RSC function, the render JSX to client JSX function on all the children. So they're going to go back through the whole process again. We'll get those out of the way. And then down here, we're going to make a static component. Okay. So we're just going to render to string the component. So like we're just going to have a visual representation of what the component looks like. Okay. And then underneath that, we're going to have the JSX. We're just going to take the function and we're going to render it to string so we can send it over the wire. We can serialize it and have it be accurate whenever we read it later. Okay. And then the client component itself is just going to be that JSX with some props. And those props are going to be some of these data props that say if it is a client component and what its name is. I think we can take those out actually because we use them again down underneath. But we're going to leave this the way it is. And down here, we're going to look to see if a file has been written. That's right. We are going to write a file, old school, every single time that we run this. It's kind of like bundling, but not quite. So we already have our JSX transform done because we're using this node JSX loader that's doing the plugin with transform react JSX, and it's automatically running it and transforming everything. So whenever we get the JSX, it's already going to be ready to have all of the functions run. So what we're going to do here is that we are going to go ahead and import in the SSR over here, we're going to import the JSX runtime and have it running in the browser so that we can run these functions and have them run in the browser. It's, it's a little janky, but it works. It works just fine. So let's keep moving through the client transform here, okay? So we're going to look to see if that file already exists. If it does, then we're just going to keep moving in this version. Otherwise, we're going to write it to disk. And then all we need is a div that has these client props where we can see if it is a client component and what its name should be so we can properly hydrate it on the page. And then the HTML is just going to be that static component that we created earlier with React render to string, react-dom right here. Okay. And then after that, we have the look for file function, just is very simple. And then the write component to disk function down here. This just takes that props in JSX and it just places them. We stringify the props and we place the JSX right here so that we can import it on the client. It's very, very simple, but I wanted everything to be as obvious as possible so that when you look at this, everything just makes sense. Okay, so let's go over to the browser and see how things work over there. Okay, so over here on client.js at the very top here, I did it where we're just looking for everything with that data client where that is true. If that data client prop exists, then we're going to try to hydrate it. So we make a client component JSX cache here, which is a new map. And so we go through each one and we're going to get the name of it from that other attribute that we set, data component right here, see? And then from that, we can import each file so that we can run each function and then properly hydrate the page. So if we look over here, we can see the file that we created, which has all the props right up here. And then down here, it's the JSX is just the functional component itself, see? And so then we take each of those and we can create an element using react.create element. We're going to surround it with some suspense so that it can properly load into the page. It breaks everything if you don't have this, even though we're not even going to see the fallback, I don't think. And then we are going to hydrate that root, okay? So we are going to take that client component and we are going to hydrate it with the element that we created up here. And then we are going to store that in the cache for if we need to hydrate it again in the future, and then we are going to render the page. And then we just hydrate every single one of those roots every time the page is loaded in. And we can create the cache here, and then we have in the navigation, we are using and I'm not really appropriately using the cache here very well, but I mean, it exists if I were to want to use it. So if we go over here, we can see that everything is working perfectly. We're on 8080 again, and it should load in, and boom. So as you can see, everything works. We have a client-side hydrated server rendered page. It's just a little bit mad about how I'm doing it. But hey, if it works, it works. You can yell at me all you want, React. All right, let's keep moving into the next little bit here. Okay, I don't want to spend too long on this because this is obviously not the way anybody should use server components, but I have another version here that I created where the final version of the client transform goes through and it does the same thing where it's going to make the hydration props. But here we also include a data loading attribute and put that as true, okay? And then down here in the write component to disk, we are actually hashing it each time that we go through, and we're going to compare it each time, and we're going to see if it's changed since the last time that we ran the server. So we're not going to waste our time writing unnecessary files for things that haven't changed, okay? So we now have partial hydration for things that take a long time on the server. We can replace them with spinners. I was having trouble doing that other than doing it this way. I'm sure that there's probably a better way, but this is how I ended up doing it. And then I also ended up putting a couple other client components on the page just to show that we can do multiple client components with my silliness here. So we still have our count over here, and then we have this over here, which changes whenever we have a cookie changed, okay? And then down here at the bottom, we also have this thing, which we can put some stuff in, and then we can alert it if there is stuff in there. And then I will show you that if we go over here into the actual components themselves and we change something, you will see that we are going to actually, when we save, it's going to go back through, it's going to check each file as it loads them in when we turn the server on, and whenever it is going to make the request for the page, it's actually going to break the whole server because we're going to have a new file and we're going to have to refresh everything. So let's go ahead and do that. Then we are broken, and then it loads back up and we have new files for everything. And so then it should all just load in, and then whenever I do that, it's going to say you are so cool. All right, so let's finish up. We're going to talk about what I did here, and then we're going to finish up the whole video, and we're going to set up things for the next video. So everything basically boils down to this error right here. Cannot read properties of null reading use state. If we don't check to see if there is a window, if we're in the browser, then it breaks everything. And that's what the bundling is all about. That's what this use client and Pragma is all about. It's about knowing when we're in the browser environment so we can use things like state and effects. And so that's what this all boils down to, is that it's all about routing and bundling. We need to make sure this is our first thing that runs on every request right here, and all it needs to do is get the URL and return the right element for that URL. by checking with path name is how we're doing it. Really, really simple how we're doing it here. And then, so what we need to do is we need to pass through every request each time by checking the URL here and passing through that URL each time from one server to the next to get the appropriate JSX and route it all through to get the right request. So routing is one big important thing. And the second big important thing is bundling for things like client components, but also for things like server actions. Because the way that that is going to work is so that you don't bundle everything together. You're actually going to have the bundler be looking for the use server directive for those to know how to direct each thing to the appropriate function. The way I'm doing it is with this action router, but it's just a simplistic way of doing the exact same thing, importing a module that has a function that you want to run for that request and response. This is all as simple as can be, but this is really how it all breaks down in the actual thing. But you just need to route the appropriate thing in the bundle, and you use these directives to help the bundler understand which thing needs to go where. And that's part of why my thing is so broken, but we need to create new files every single time the props change, every single time anything in each component changes. And so that's why the bundling is so important, because we need something to run in the browser, but we need it to be appropriate for what's happening on the server for each time. So every single time you change something with your RSCs, you change the entire bundle, and you need to run that entire process again. So even with my unbundled version, it still goes through this whole rigmarole to try to get the appropriate things to the browser. So creating an unbundled version of React Server Components it's really, really difficult for this reason, because we need to know what we want on the client and what we want on the server. And so bundling it and keeping everything separate by using these little directives is the easiest way to keep all of these things separate. And I just want to point out the obvious reason why it's important to bundle the server actions separately is because if you have any of your database secrets in there, you don't want those making their way to the browser because you don't want to be hacked. So I'm going to have all of my code available for each challenge. It's all split up, everything, even the multiple chapters. And over here we have the node server at the very end, and even an express server with everything set up for you to play around with this stuff. And some of the best ways to learn about this is by looking at the official demos here. So they have really, really, really good comments in here. So make sure you pay attention to all of this if you don't want to wait for my next video. And then over here in the official React Server Components demo, this is a really good thing to look at too. But the problem with it is that they want you to set this whole Postgres database, and it's really cool after you set that up, but I just wanted to make it a little bit more accessible. So I went ahead and I'm going to fork it, and I'll have that available in the same repo, and you can just use all file system. It's all written to a JSON file. Okay. So I'm going to have that available for you too in the GitHub repo. I'm going to have all of this available. And then in the next video, my plan is that I want to show how to get everything to work properly, how to actually do things the right way. And my goal is that after watching my next video, everybody will be able to build a React Server Components framework if that's really what they want to do. Okay. Generally, what you should do is probably just use a framework or something that's built for you, and that people are doing all the hard work to make this actually work well, instead of spending 2 weeks trying to build something that's not even a third as good like me. So I think that that's generally the way, but I think it's really cool to actually understand how all of this works. And the React team has done a pretty good job of communicating a lot of this stuff. Like I said, these comments are really good. And if you really dig into the GitHub repo, it's really cool. But some of this stuff is hard to run yourself, honestly. And it just gets a little bit frustrating whenever you're just trying to learn and you have to do a bunch of steps in order to actually get anything to actually run. So that is my goal with my GitHub repo that I'm going to provide to you, is that everything, you'll just be able to install it and run it and then look at the code, and it should just make sense. That is my goal with my code. Okay, so I'm going to end this video now. We're at an hour. It's way too long already. I'm sorry, but thank you if you watched this entire thing. And then the next video is going to be about how to do this right. And I just want to show you guys how cool and how easy, really, once you know what you're doing, server components can be. Okay. And we're going to do it all the right way the next time. And once again, if I got anything wrong here, please let me know. I'm trying to learn here. I'm not trying to mislead anybody. I'm not trying to pretend to be smarter than I am. I'm just trying to learn. So please just let me know what I got wrong. Thanks, guys.